right, so just to back up and get a running head start here, the biggest thing that we're doing in 4.4 is factoring. Almost every single question in section 4.4 is solved by factoring. That is not the case in 4.3. 4.3 is a section where factoring, it's highly possible that it's not possible, okay? So you have to know both methods to be able to do what you need to do on the test. I was working on writing the test even just this morning, and one of the things that I made a mental note, like I need to tell the students this, you've got to show your work. You've got to show your work. I've said it before, but let me just remind you, no work, no credit. Even if your answer is right, there's a lot of things that you can do in the calculator that I want you to do in the calculator. There are some questions that I've taught you to do in the calculator, so I'm not anti-calculator. I just want you to be able to work it both ways, whether it be in the calculator or on by hand analytically. So please make sure that you're showing your work. My work page will be a little different that I hand to you, you know, where you have something to write on. Because what I'm going to do is the whole left column of blocks will be normal, and the whole right column of blocks will actually be graph grids. Now, if you don't need the graph, you can just write on top of it if you want to, but at least if you need a graph grid, you've got those available to you so that you can visualize what you need to visualize. That's all I can think of at the moment, okay? But right now, the test has like 23 or 24 questions, but I'm not finished editing it, etc. So that number is subject to change. Okay, so number 8, find all solutions graphically. So this is one of those times I don't want you showing your work on this. I don't want you solving by hand. I mean, in fact, I probably, if I give you a question like this, I probably made it ugly enough that it's going to be very challenging to show your work by hand. And so let's go ahead and grab our calculators. Go to your y equals. Now, before you start typing, can we just discuss a couple things? Like, how many zeros do you think I'm going to be looking for? 3 zeros. What's the end behavior going to look like? 1 up, 1 down. Is it going to go overall uphill or overall downhill? Why downhill? You've got a negative out in front. So, so my brain, these are ways that I can check my work. If I'm thinking of these before I graph, if I graph something totally different, it's going to be a red flag. Okay? So go ahead, type it in. Show it to somebody nearby. See if you got the same graph as everybody else. Can you guys see each other's? Can you see that far?
Yeah.
That's okay. Mine's only negative 4 to 5. Just like you would see it in the
Okay, so I think we pretty much all have the same thing. When it says to find all solutions, what are we going to be looking for? We're going to be looking for zeros. So if I just were to make a little sketch for you, mine kind of looks like this right here-ish, okay? How many zeros are we actually looking for? 3. Now, we knew we could have up to 3. We expected to have 3, but we didn't know if any of them were going to be complex. In this case, they're all 3 real. They're all able to be found on the calculator. Let's do this systematically. So I want you three to look for the left one. I want you 2 to look for the middle one. And I want you 2 to look for the right-hand side. And you're welcome to talk it out. So if you're a little bit sketchy, I'm like, oh, I don't remember how to do that, ask somebody in your group. And check with each other, make sure you got the same thing. What is that code for? But I'm sorry, that's not exactly what I'm asking. When you see it here, what is that code for?
I'm not sure I understand what you're asking.
Okay, so can I wait and answer your question in a minute?
Yeah.
Okay. And maybe ask somebody in your group, they might remember, or it really doesn't matter if it's somebody in your group, it can be anybody, and see if they remember. Now, if you're finished, go ahead and try another one, and you can check another group just to be sure that they did it correctly. Ask some people in your class, ask other people, because you both got something similar, but different. So ask some other people in your class what it means.
You get the same Y as
Hey, Dylan, what is a zero? An x-intercept. What do all x-intercepts have in common? So what does that mean?
So that's equal to 0.
That is code for 0. Yep. All right, so this group, what did you guys get for the leftmost 0? Okay. And middle group, what did you guys get? The middle group, when you guys did this one, did you get a normal 0 for your y value, or do you get a funky y value? Normal, okay. And then the right group. Okay, did you read the directions on rounding? And did you guys get a funky 0, or did you get a y equals 0 normal? For me, 2 of them, I think it was your group and your group that I got a funky y value, okay? But remember, when it says E negative something, that's code for 0, okay? And that's all you had to do for that one. All right, find solutions analytically. All right, so we know this means we're not going to the calculator. We know that this means that we need to solve by hand. solve by hand, showing all of our work. Now, there's something to remember here. Tip number 1. If you're working with a square, just solve using the square root method. If you're working with square, you can use one of your quadratic methods. Probably you're going to use the square root method on these. But if you're working with something higher than a square, now notice this, all 3 of these have the same format. They have x to a power equals a number. Okay, so I'm talking about this format specifically. Okay, if you're working with a square, use the square root method. But if you're working with something larger than a square, move everything to the same side and solve by factoring. Okay, move everything to the same side and solve by factoring. All right, so when we look at example number 9, since it's a square, I can just use the square root method. Okay, and if I use the square root method here, we know we're going to take the square root of both sides. So this is going to be x is equal to, good, plus or minus 2i. Now, when you look at the original equation, how many solutions do I expect to have? 2. And that's something, if you can think of that at the beginning of the question, if you get to the end and you've only got one solution, this should be a red flag. Go back. Oh, yeah, I forgot my plus or minus. Okay. So plus or minus 2i. This would be one where I would not be able to see the zeros on the graph. All right, look at number 10. This one, if I didn't follow my tip, I would take the 4th root of both sides. The thing is we've never worked with 4th roots. Okay, so that's why I said anything, it's not like we have a 4th root method like we have a square root method. Okay, so that's why I said take everything to the same side and solve by factoring. All right, so if I take everything to the same side, what does that look like? Yeah, equals 0. And what do you notice about that binomial there? What can be done? Yeah, because it's a difference of 2 perfect squares, right? So how does this factor down then? Now, it's always a good idea to factor completely. So is there any more factoring that I can do on this? Yeah, so what more can I factor? Okay, so let's look at these one at a time. Do you want to start working with this one first, or do you want to start working with this one first? The minus one? Okay, so Sierra, what do you want to do with the minus one? Yeah? Okay. And then Dylan, you wanted to work with the plus one, so what can you do with that one? So an x plus 3 times an x plus 3 would give you a positive 6x in the middle. If you FOILed it out, it would give you a positive 6x in the middle. So just think, to have no middle term, Dylan, one's got to be positive, one's got to be neg. It's not factorable. It's not. There is no such thing as the sum of 2 perfect squares that can be factored. We only have a difference of 2 perfect squares that can be factored. Mary Alice, were you going to say something? Yeah. I had to FOIL it out in my head real quick. But yes, you could. You could. All right, so then I've got 3 factors. Let's make mini equations and solve each factor. So that first factor, x squared equals negative 9. So what does x equal? Close. Plus or minus 3i. And then the second factor is easy, so that's x equals 3 and x equals negative 3. Does that match up with what we know about how many solutions there should have been? Yeah, it does. It does. If I graphed it on the calculator, I'd be able to see 2 of them and not see the other 2. Okay? Any questions? All right. Number 11. So for number 11's funky. Okay, I'm going to bring some knowledge that you had to learn back in Math 101 and Math 102, but students always forget it by the time they get to Math 110. Okay, so I will remind you how to do this one. So the first thing is this is one of those times where if I took the cubed root of both sides, what is the cubed root of negative 27? What is it? No, because 9 times 9 times 9 is not 27. Negative 3, right? A negative 3 times a negative 3 times a negative 3 is a negative 27. How many solutions is that? No, there's just one solution. Negative 3 is that one solution, right? But how many solutions should I be looking for? 3 solutions. So if I just took the cubed root of both sides, I would lose 2 of my solutions. I wouldn't be able to find 2 of my solutions. Okay, so let's go ahead and rearrange it first so that it's an x cubed plus a 27 equals a 0. All right, and then let's take a rabbit trail and remind you of a rule for factoring a sum of cubes or a difference of cubes. Okay, so that's what it's called, a sum or a difference of, I'm going to say perfect cubes. Now, 27 is a perfect cube because it's 3 times 3 times 3, right? Can you name some other perfect cubes? What are some perfect cubes below 27? 8, because that is 2 times 2 times 2. Okay, what's another one? What number will you multiply by itself 3 times to get 16? Yeah, you're thinking squares, so be careful. So this is cubes. So 8 is a perfect cube, 27 is a perfect cube, 1 is a perfect cube because 1 times 1 times 1, but the negatives work as well, right? What about negative 8? Negative 2 times negative 2 times negative 2. So negative 8 is a perfect cube. Negative 1 is a perfect cube. Negative 27 is a perfect cube. I won't go too far, but what's one perfect cube above 27? What number multiplied by itself 3 times gives you 32? 4 times 4 is 16.
Oh, wait, never mind, I'm different one.
Okay. So what's a number above 27 that's a perfect cube? 64. 64. Can you do one more?
128.
125. 5 times 5 times 5. You can't end with an 8 when you're multiplying 5s. All right. So, by the way, Dylan is great because I've had him for a previous math. What did I have you for?
101.
101. Okay. So that was last spring.
Yep.
When COVID hit, right?
Yeah.
Yeah.
And I had 102 in summer, but that was with a different teacher.
Gotcha. Yeah. So Dylan and I get to pick on him because he lets me. But let me tell you something. I've been reading this book and I really don't have time to read. So the only time I can read is when I'm driving. Because I can listen.
That's what I was gonna say.
I can listen. Okay. No, I have a self-driving car now. I can listen to books when I'm driving. So that's about the only time I have to read. And I've owned this particular book. It's totally a geek book. But I've owned this book for like 2 years now and just haven't had the time to read it. And just learned last week that it came out on as an Audible book. So I started it last weekend. And it is from a psychologist's perspective, also a math teacher. But she's saying some of the same things that I've been saying, but she's got scientific methods and scientific proof and experiments to back up what she's saying. I don't have any of that. I just have experience to back up what I'm saying. And one of the things that she keeps saying is that students who get answers right fast aren't learning anything. Their brain's not growing. Students who make mistakes, learn from their mistakes, and struggle, get this, their brain physically grows. Physically grows. And so you guys, you think I'm so sadistic that I get excited when you make a mistake in class? Okay, it's not that I'm being mean. My brain is saying, they're growing. I'm so excited. So I don't worry about mistakes that you make out loud in class. That does not bother me in the least, because that's your opportunity to learn something and your brain can grow through that. If you're just getting answers right all the time, your brain ain't doing nothing. That's the scientific proof. I mean, they're talking MRI scans and stuff here. I'm not making this up. So to me, yes, I can say your brain's growing, but I had nothing to back that up other than the fact that I can see you growing. So anyway, so I pick on Dylan when he makes a mistake, but I am also very excited because I know he's growing through that. And because I've established a rapport with him. Some other people might burst into tears. If you burst into tears on me, I don't know what I'm gonna do. But you know, so just understand, I do get excited when you guys make mistakes, but it's not because I'm mean. It's because I know this is the opportunity for growth. All right, so anyway, back to real stuff. Summer difference of two perfect cubes. So you just listed some perfect cubes for me. And the summer difference of two perfect cubes, I'll do the sum first. And that is if you ever run into an a cubed plus a b cubed, where I have the sum of two perfect cubes. You can always factor this. When you factor, you will have a binomial times a trinomial. Okay? Inside of your binomial, you will have plain old A plus plain old B. Not the cube version, just the plain version. Okay. And then inside your trinomial, you'll have your A squared minus your A times your B plus your B squared. Okay, so that's if you have the sum of two perfect cubes. Now, if you have the difference of two perfect cubes, it's almost exactly the same. Almost, but not quite. Okay? My binomial piece is going to be your plain old A minus your plain old B. Your trinomial will be your A squared. Anyone want to take a stab? Plus AB plus B squared. Now, when I teach this, which is, I only ever touch on it this one time in Math 110, unless I'm teaching 101 or 102. And when I teach this, I tell students, as long as they have SOAP, they'll understand, they'll remember it. Okay? So S in SOAP, I'll tell you what they mean, and then I'll go back and explain how to use it. So S in SOAP means same. O in SOAP means opposite. And AP in SOAP means always positive. Okay, now let's talk about how I get that. So when we're talking about the sum, notice that my signs here are the same. My first sign, my first pair of signs, they're the same. This guy is the same as the original. The next sign that you see is opposite the original. So there's the opposite part. And the last sign that you see is always positive because it's a square. Okay, so this guy is always positive. So notice the same thing here. My first sign that you see is the same as the original. This one is the opposite of the original. This guy is always positive. Okay, so that's a way that you can remember what the signs are in that. All right, now let's go put it into practice. Okay. Oh, and one more comment here. The trinomials, they will never, 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 never be factorable. You will never be able to factor them further. They'll look like they are, but you'll never be able to factor them further. Okay, so that's just a tip to remember. It'll save you some time if you can remember that. Okay, so let's go back to number 11. Notice I have a sum of two perfect cubes. Now, do you see how my problem is not written like this guy is written? Okay, so the first piece is written properly. But how can I write this piece to look like this? What number cubed is 27? No, negative 3 times negative 3 and negative 3 is a negative 27. It's a positive 3. So this is the same thing as x cubed plus 3 cubed. Right? You don't have to write that, but you at least need to think it. Okay, now let's use our formula. Now mine's hidden, but you have yours on paper. I know it's going to be a binomial times a trinomial. What's the binomial piece going to be? Yep, plain old x plus plain old 3. What's the first term in the trinomial going to be? X squared. What's the sign going to be for the second term? And what's my a times my b here? My plain old a times my plain old b. Yeah, 3x. You could say x times 3, but it's easier to write 3x. And then what's the sign for the third term? Always positive. And then what's the number for the third term? 9. 3 squared is 9. Now, do you see what I mean? How it kind of looks like this is factorable, but no matter how hard you try, you are never going to find factors that will work for this. Okay, so this guy is not factorable. So you can't use the zero product on this piece. All right, I'm going to have to come up with a different method, but I can set up my mini equations. So you've got x plus 3 equals 0. Yeah, you can just write down x equals negative 3. By the way, that was a solution we knew about. Remember, we found that the first one, but we were missing 2 more. The other piece is going to give us the 2 more. And so my second mini equation, x squared minus 3x plus 9 equals 0. How many methods do we have for solving that? Normally. I normally have 4, but we just got finished saying that the zero product property isn't going to work. I won't be able to factor it. Okay, so now I'm down to 3. Square root method, not an option because there's 2 x's in there. So now I'm down to 2. Either completing the square or the quadratic formula. Am I a person who would choose completing the square on this one? Why not? Yeah, I have an odd b. And remember I told you that I really only like completing the square when I have even b's and a's that are equal to 1. Okay, so you could, and it really wouldn't be that hard, but you'd have to work with fractions. Okay, so let's do the quadratic formula. For the record, I'm not anti-quadratic formula. Okay, it's a last resort. It's a last resort because I think it's the hardest method personally. All right, Quadratic formula. X equals, now, so Dylan, since you don't like the quadratic formula, you're doing this one. Okay, we're giving your chance, a chance for your brain to grow. So X equals, go ahead, Dylan. Which is going to be? Okay, keep going. He needs help. Plus or minus square root of b squared, which is 9, minus 4 times a times c. So what is my, what I'm going to write there? Just a 9. I don't need the a part. All over 2 times a, and in this case, 2 times a is 2 times 1. So Dylan, the problem is not that you don't know how to work quadratic formula. The problem is you haven't memorized it yet. So dude, go watch some of those videos and learn a song that goes with it. I ain't singing for you today. All right, so we've got 3 plus or minus, that'll stop all brain growth right there now. So we have, let's see, 9 minus 36, and 9 minus 36 is what, 27 negative? Okay, I'll come back to that, and well, I'll go ahead, all over 2. You know you can't leave it like this, okay? How is that root negative 27? What's that going to look like? She says 3i root 3, but she didn't really explain to us what she was talking about. All right, so somebody else who can explain.
Minus 27 can be separated into the square root of negative 9 and 3.
So the 9 times the 3, and the 9 part, good, good. You were right, Sierra. I just wanted some explanation there. I wanted some brain work on there. Okay, so that's what I'm going to turn the square root part into. And there's one more thing to remember. Remember that when you're writing in proper complex notation, it's got to be a separate a plus separate bi. Okay, so I need to take my fraction, my denominator, and share the love. So that'll be a 3 over 2 plus or minus 3i root 3 over 2. At that point, if I can reduce fractions, I will, but in this case, I cannot. How many solutions are right there?
2.
Well, just right here, there's 2, right? And they are complex, which is why we couldn't get them without going this route. But there are 3 total. There are 3 total. All right. Any questions on that? Okay. So then let's go back to 4.3. So I asked you guys to work this one out, okay? Did you? If I were taking a grade, would you get a good grade? No? November, did you work this one out?
I'm not sure where they went.
Blake, did you work this out like I asked? No. Mariella? No. Sarah? You did ask me for a picture. I'm not doing it for you. Well, I'm about to do it for you, but I wanted you to try it. Nobody. I shouldn't even work this one out. So, ugly's not illegal. I mean, go to Walmart. You'll figure that out real quick. All right. Okay. So the first thing that we're going to do, like I told you on the last class, let's multiply on both sides by 7 so we can get rid of our fractions. So that'll be a 7 times a p of x is equal to, when I multiply all of those terms by 7, what's the first term? And what's the second term? Somebody else? And then a third person. What's the third term? Why plus? minus 49x squared, and then somebody else for the fourth term. And then one more person for the last term. 5. No, -5. Close. That wasn't that bad. And look, now it's pretty. All right? Now I don't have to worry about all those fractions. And you could do this from here. Now, I want you to pay really close attention. Because if I ask you to do one of the questions like this, I am looking for all of the work. Okay? There's several ways that you can get this. I'm sorry that makes you sad, Miles. There's several ways that you can do this. But if I ask you for the work that where you have to show your work using the possibles, I better see all the work. Okay? Gotta see all of it. Okay. So first step, let's go back to the directions so that we can remind ourselves. And I was just looking at a test question exactly like this set of directions this morning. Okay? Number 1, let's list the possibles. Okay. So let's go down here and let's list our possibles. How is it that I get my possibles? Really close. You've got the idea. But it's not the constant over the leading coefficient. It is the factors of the constant over the factors of the leading coefficient. What are all the factors of the constant? Oh, I'll deal with the plus or minus in a minute. So 1 times 5, right? 1 times 5. What are the factors of the leading coefficient? Okay, 5 times 2 and 1 times 10. All right? Now, so let's take, remember the factors of the constant are going to go on top, the 1 and the 5. The factors of the leading coefficient down on bottom, 1, 2, 5, and 10. Is he trying to tell you something? Is he okay? Are you okay? Okay. All right, now remember, you can't, this is not a good answer. This just helps us set up our answer. Okay, and here's where we're going to remember the pluses and the minuses. All right, so you want to take your 1 over the 1. Let's just deal with the 1 on top. The 1 over the 2, the 1 over the 5, and the 1 over the 10. Okay, so that's the plan. So we've got plus or minus. Go ahead, tell me. Okay. Okay, somebody else? Plus or minus? And then the last one. Plus or minus.
Ms. Roberts, do I have to put the plus or minus on every one of them?
Yes. Just saying. Don't be lazy. Okay, so that takes care of the 1 on top. Now let's do the same thing with the 5 that's on top. Okay, so what's my first one using the 5 on top? Plus or minus. What's the next one? Okay, what's the third one? Plus or minus 5 over 5, which is 1, but I've already got that one, so I'm not going to write it a second time. And then what's the last one? Yeah, plus or minus 5 over 10. That's the same thing as plus or minus 1/2. I already have that one. I'm not going to write it again. Okay. So how many possibles are in my list? Yeah, there's 12. There's 12. Okay. So that takes care of part A. Let's go back to the directions. Part B, find all the rational zeros, or I keep calling them the actual zeros. Where do I go for this? Yeah, I go to the calculator. Remember, I go to the calculator and I try to match up one from my list with a good guess on the screen. Okay? And you said, Ms. Roberts, which one should I graph? Should I graph the original problem, or should I graph the pretty problem?
The original.
Eeny, meeny, miny, mo, but it's safer to graph the original just in case you messed up when you did this one. remember that both polynomials have the same set of zeros. Both of them have the same set of zeros. I'm not saying they're identical graphs, they just have the same set of zeros. So I would graph the original in case you messed up and made a mistake to get the pretty one. So go ahead and graph it and show it to somebody nearby. Make sure that they got the same thing you did.
You just put in parentheses.
Yeah, so I do, parentheses 10%, parentheses, and the X. X is parentheses.
Now I've got a picture there for you. My picture is probably going to look a little different than yours because my x-axis is pretty spread out, it looks like. Okay, so like if you used the same window that I used, yours would look more like that, but I did spread mine out. Okay, the numbers look the same, yeah. Yeah. Okay, so remember what we're looking for. Did you show it to somebody? Do you guys all have the same graph? Let's make sure we're working with the same graph, because if we're not working with the same graph, then we're gonna run into problems. Okay, we all got the same thing? Okay, so if we're looking at the graphs, we're trying to find something on the graph that matches our possibles list. So do you see something in the graph that matches the possibles list? 1/2?
I mean, it looks like it when it's the way that it's in standards, and it looks like it's a half.
It's kind of hard to tell, isn't it? All right, let's try it. Let's try it. Here's where it's different. On another method, I just told you to go to second trace, and you would find it that way. That's not what you're doing here, because that's not showing your work. We're going to use synthetic to prove it. That's the work you're showing next. Let synthetic prove it, okay? So this is going to be part B. Let's try x equals 1/2. The cool thing is you don't have to use the ugly version. You can use the pretty version. Okay, so pretty version has a 10, a -7, a -49, a 35, and a -5. Okay, so what's first? Bring the 10 down. Okay, what's half a 10? 5. Add? -2. What's half a -2? -1. Add? -50. Hey, this isn't so bad. We're working with fractions and it's not that bad, right? What's half of -50? -25. Add? 10. What's half a 10? 5. Add? Woohoo, it worked. Okay. Now, do you remember what the directions were for part B? What am I supposed to be doing? Finding the rational zeros. So for part B, let's start making a list. I just found one at x equals 1/2. This next step is one that students commonly forget. Remember my depressed polynomial, what's it supposed to be right now for me to continue on? a quadratic, is it? Not yet. Do you remember what to do when it's not a quadratic? Yeah, go back to the calculator screen and let's try to match up another one. Go back to the calculator screen and let's try to match up another one. Now, if it's helpful to you to zoom in on your graph, go ahead and do that. See, it's not 2 because it's not going straight through 2. That's what I'm saying by zoom in on your graph. Make your x-axis, instead of it being negative 10 to 10, maybe let it be negative 3 to 3. 5 halves, what is 5 halves? The same thing as 2 and 2.5. Does it look to you like 2.5? Does it look smack dab between 2 and 3? So 5 halves, it might not work. 1/5. 1/5, and again, we're trying things from our possibles list, okay? So let's try 1/5. This one was the 1/2 one. This one is the 1/5 one, and unless you really spread out your x-axis, that's hard to see on the calculator, okay? So you do need to spread out your window on this one, so let's try 1/5. Do you remember where we plugged this into? Yeah, don't go back to the beginning. Don't go back to the beginning. Go to your depressed polynomial for this. I'm going to change my colors here. This time, we're going to try x equals 1/5. And this is for my depressed polynomial. Okay, so let's pull our 10 down. Well, guys, don't get crazy about 1/5. That's just divided by 5. Okay, so what's 10 divided by 5? 2. Add. Ooh, what's 0 divided by 5? 0. Add. Okay, what's negative 50 divided by 5? Ooh, add. Woohoo, we proved it. It looks good. Okay, so let's go add that to our list of zeros. So x equals 1/5, it worked for us. This is all part of the showing work on this. This is, like I said, this is the climax of the semester, what I would consider the most challenging question for the semester. Okay, where do we go next? Yeah, I can solve the quadratic, right? I can solve the quadratic. So take a look, your depressed polynomial is now a quadratic. Once it hits quadratic status, you can use one of your 4 methods. Okay, so let's write it down first. All right, so we've got 10x squared minus 50 equals 0. What method would you choose to solve your quadratic? I would totally go with the square root method. The square root method, because there's only 1 x there. I can get that 1 x by itself. Okay, so you're going to add 50, divide 10. That'll give you an x squared equals 5. And then what will I do? Square root both sides. So I'll have x equals. Okay, so let's go back to our zeros. We now have an x equals root 5. And an x equals negative root 5. Four zeros, is that what we expected? Yeah, it is. Okay, we're not quite done with the instructions. Let's go back one more time. So I got part A of my possibles. I got part B. I found all my actual zeros. Part C, let's go factor. Okay. So, what's the first factor that goes along with our 0? Yeah, you could either say 2x minus 1 or x minus 1/2. That's the one I'm going to write down, Mary Alice, mostly because that's the one that most students think of first. Okay, but I'm totally fine with 2x minus 1. okay? What's the second factor? X minus 1/5. Mary Alice, you would have said it was, and I'm okay with that, okay? What's the third factor? I have x minus root 5. Did you write yours in a different order than I did? That's fine. And then x plus root 5 for the last one. Now, that's a list of factors, but I have not factored p of x. I have not written it as my product of factors. So we got p of x is equal to, let's just go ahead and multiply our 4 factors together. X minus 1/2, x minus 1/5, x minus root 5, x plus root 5. Now, what do I keep telling you to check after this? Leading coefficients. Now, this is important. Don't check the leading coefficient of the one that you manipulated. You have to go back to the original. So what's the leading coefficient on the original? 10 over 7. 10 over 7. 10 is the one we manipulated, right? Mary Alice, if you had used the 2x minus 1 and the 5x minus 1, what is your leading coefficient? And so what are you going to do to make your leading coefficient match the original? Yeah, I would multiply by 1/7. I would put a 1/7 in front, okay? So having the 10 out there still doesn't match. It matches our manipulated version, but it doesn't match the original, okay? So just be careful with that.
So where did you get the 10 7 again?
Uh-huh. So the original leading coefficient has to match.
So when you originally multiplied it by 7 and got the 7p of x, you forget about the 7p of x after this?
Yeah, so remember this. Like I said, they're not the same graph, but they do have the same zeros, and that's ultimately what I'm looking for is the zeros. The one with the 7 in front of it is stretched, a vertical stretch by 7. And so it might, be something, and honestly, I don't even know if the red one that's drawn is the stretched version or the original version, because I can't remember what I typed in. But let's say it's the original version. Oh, I missed that one. But you get the idea. That might be what it looks like where it's stretched, but my 4 zeros are still all in the same place. Okay, so that's why I'm allowed to do that. Good question. And you can even try it yourself. What you could do on your own time, not right this minute, is graph both polynomials on the same screen, in the same window. You'll see that they have the same 4 zeros. Okay, so. All right, any questions about that? So I can't have too many questions like this because they take a while, right? But this is the climax of the semester. I promise you, you've got something like this. Okay, now I might split it up where I might have 3 different questions, okay? But nonetheless, all of the parts are gonna be there.